Hi, everyone. I hope that you are having a wonderful day. Today, we are going to do a virtual density testing lab. Density is a concept that we learned quite a ways back. And we all know that density equals mass divided by volume. We've said that a lot, and we've done it a lot in warm ups as well as how to test over it. Density equals mass divided by volume. For this upcoming unit that we're going to work on with rocks and minerals, density is a really good way to figure out what kind of mineral or what kind of rock we're looking at. So for instance, if we look at this sample right here, or even I can click on these other samples that we are looking at, we might not know by just looking at it what they are. However, if we can find the density of that sample, then maybe we can figure out the actual mineral that we're looking at. Okay. Tomorrow we will be working on how to identify minerals in other ways besides density, but today we're just focused on density. In front of you, you should have this lab sheet where we've got each of the number of minerals listed here on the left, and then we've got mass of the mineral in grams and volume of the mineral in milliliters. And then obviously we know that if we can find the mass and the volume, then we can calculate density. The other thing that you have in front of you, which is going to be the last step that you're going to do today, is once you find the density of all of your minerals, then you're going to use this table that's on your desk, and it's kind of, I think, copied on a gold paper. But if you can find all those densities, then you can look at them here and determine which minerals we're actually looking at today, which is kind of neat. So let's dive in. If we look at mineral 12, so I've clicked on mineral 12, and we're going to follow the instructions the whole way through this. It says, determine and record on a separate piece of paper, that's our lab paper that's in front of you, the water level in the cylinder on the left to the nearest 10 milliliters. Now, I'm going to do it kind of to the nearest 5, but to the nearest 10 will work as well. It says, so we're going to read this first. Okay. Now, our water line, if this was a real cylinder, our water line is going to be where this red line is here. Let's kind of figure out what the amount of milliliters we're going to start with before we drop, this is our mineral, before we drop our mineral in. So here's the 700 milliliters, 800 milliliters. And so probably right in the middle is 750. If we go down just a little bit, that's going to be about 745 milliliters. So I want to go ahead and record that on my lab sheet as our starting point because it says to record it on our separate piece of paper. So I'm going to go back here to my lab sheet. And then what I need you to do is right in the middle column where it says volume of mineral here, we're going to have level immersed, which we're not doing yet, and then original level. With this, what we're figuring out right now, that was the original level. So we're going to put that on here, which was, I'm going to put it kind of towards the middle, 745. Yes, that's a 4. 745 milliliters. Now let's go back and figure out the level when we immerse. So it says press the immerse the mineral button. Sorry. Immerse the mineral. So I immerse the mineral button. Now it says determine and record the water level on the right. So you can tell already that once we've put the mineral in, the water level has risen. Now it's between 800 and 900, so that's going to be about 850. So it kind of looks like the same sort of place in the middle. So we're going to say 845 milliliters. That's going to be level on the right-hand side, which is here. Now, immersed means to dip in or to submerge, if you didn't know that. So we've immersed the mineral, and this is the new level of water. So we'll record that. $845. And it says up there to subtract the 2, which 845 minus 745 milliliters equals 100 milliliters. So the volume of the mineral is 100 milliliters. Now let's go back to grams. Let's figure out the mass of the mineral. If I continue with the instructions, step 3 here says press the weigh the mineral button. Okay, weigh the mineral. It is very important, guys, that you need to understand that we know density equals mass divided by volume. On this particular lab, they're saying weight divided by volume, but for our purposes, please, please, please make sure that you know it is mass divided by volume and not weight. So once we press that weigh the mineral button, what it comes up is this balance, kind of like a scale. If we were to put this mineral on a scale to weigh it, this is what it would say. So let's add these together. We've got 30 grams plus 200 grams, so that's about 230. And then down here, these are ones place digits, as we know, and this is going to be decimal points. So let's do this. 2.1, 2.2, 2.3, 2.4, and it looks like it's about on 2.5. So if we were to take that, it's 232.5 grams. Let's go ahead and put that on our worksheet. 232.5, it's a decimal point, 0.5 grams. Okay. Now, I don't want anybody calculating the density yet. I want all of you to go through each of these minerals and record your data first. That's incredibly important. I don't want to see any densities calculated until the very end. So now you're going to go back here. You'll click on mineral number 6, and you'll do the same. Read the water level here. Press the immerse the mineral button. Read the new water level, then weigh the mineral, and get those information, and you'll fill it all in on your lab sheet, just like we did with this one. Okay, so you still have, let's see, whoops, sorry. 1, 2, 3, let's see, 1, 2, 3, 4, 5, 6, 7, 8 to do on your own. Once you have all of those done, once you find the mass and once you find the volume, then go ahead and calculate the density. If we were going to do it all and we have this one done, we know that this one is going to be 232.5 divided by 100. Oops, sorry. 100. Now this one's pretty easy. You could probably do it in your head, but well, you have the calculators out, so that's not a problem. Once you have this done, then you can figure out the density. So the density of this mineral, once you've put it in, it should be 2.3 to 5 grams per milliliter. Sorry, my pen wasn't working properly. And honestly, when you're doing the density right here, it's great if you want to write it out like this, but you certainly don't have to. If you just want to put the answer there, I am totally okay with that. Okay, so going back, just to review, step 1, find the volume. Step 2, find the mass. Step 3, find the density. Step 4 is now you can go back to your densities here and look on this chart. Which one of these matches number 12? So let's look on your paper, 2.325 grams per milliliter. Which one of these matches that? If you said tridymite down here, you are correct. Again, this paper is right in front of you. It's copied on like a gold piece of paper. So now what I would do, tridymite, so that's the mineral, that's number 12. So I would actually write that right here on my mineral paper. Okay, tridymite. At that point, you should have everything done. It shouldn't take you too terribly long to do all of this. Your exit ticket for today, though, ladies and gentlemen, is this bottom piece down here. Describe to someone who is unfamiliar with the lab exactly how to find the density of minerals. We've been talking about density for so long, so you know automatically in your head, density equals mass divided by volume. So down here in this space, all you need to do is just describe what you just did in the lab. And that's it. If you have any questions, please, please, please ask the teacher. You have 8 more, I believe, of these to go. And then once you get it filled in, turn it in. Again, if you have any questions, let us know. Thank you. Have a great day.